Petronas, Malaysia. These days I am serving as an associate professor at Department of Biomedical Engineering, Barrett Hostel University, Karachi. Right? So today we will talk upon the aspect of the complex engineering problems for electrical engineering, particularly. And first of all, we will talk about in general that what the complex engineering problems are. And nextly, we shall move towards the implementation of the complex engineering problem for electrical engineering. Right? So for this, let me tell you about the presentation outline. The outline consists of the, first of all, we will go for the introduction, and then nextly we shall move for the why complex engineering, why we are going to import the complex engineering. We shall move towards for the implementation of complex engineering, and we shall move for the next slide. So up to the Washington Accord, the Washington Accord is supposed to be signed by the list of the countries which are supposed to follow a certain sort of the engineering principles. Right? These principles are based upon the the graduate attributes, the attributes which are certainly to be followed by the engineering graduates in order to have the degree, which is being recognized by all the signatories countries of the Washington Accord. Right? So the curriculum, it involves a curriculum design that should include the analytical skills and advanced learning methods. Now these advanced learning methods involve all the learning methods, whether these learning methods are involved from the calculus background, let's say from the advanced calculus, from multivariate calculus, from probabilistic modeling, and let's say it involves in the communication domain, that how the communication skills are being imparted in the young engineers. It involves the business models, it involves the entrepreneurship skills, it involves whole the picture, such as to produce an engineer which can solve the complex engineering problems, whether they are related to the research field or they are related to any of the industrial problems. Right? Next slide, please. Okay. So this problem within engineering education, normally the traditional problems which we normally teach in the class, whether they are in the introduction to circuit analysis in the electrical engineering I'm talking about, whether they are electromagnetic fields, whether they are microwave engineering, or there are so many sort of fields. In that particular fields, we are going to solve the problems in a very traditional way, in a very easy way. Now let's say application of the Kirchhoff's law, let's say application of the Ohm's law. So there is very straight away problem, right? Like you can say when the linear problem, which are very well structured problems. I mean, let's say examples are the like Ohm's law is being applied, domain transformation is being applied. You can say that if I'm going to ask from you that there is a signal which has got the value of the 1. So if I'm going to ask from you that what is the value of the 1, you can easily say that Laplace of the 1 transform is equal to 1 upon s, by taking out just like integration from minus infinity to plus infinity, e raised to minus ft into dt, and so on and so forth. So this is quite easy and quite linear process. If I'm going to ask from you to compute the convolution of two signals, you can easily say that, okay, integration from minus infinity to plus infinity x of tau multiply h of t minus tau and d tau and so on and so forth. It's quite easy and the simple procedure. It doesn't involve the complexity within it. So when it doesn't involve the complexity within it, so problem is leading towards linearity. Problem is leading towards simplicity, and which gives the superficial knowledge, which gives the, you can say that very rough knowledge, very superficial knowledge to the student of engineering, which is not needed because he or she has to solve the complex engineering problems. Right? Next slide, please. Next slide, please. Okay. Why complex engineering problem? Because whenever a graduate, which is, you can say, whenever we are graduated after 4 years of the engineering, what we are supposed to do, either we are opting and can say for the electrical engineers, we are going for the field job. Within the field job, we are countered with certain problems that are not quite easily to be solved, that are not directly related towards what is being taught towards in the courses. Now let's say if we have got a problem. If we are going in the signal processing field, if we are going to the signal processing research area, so they are not like easily can be solved problems. They are not straight away problems. Straight away problems means like 1 plus 1 is 2, like integration of 1 with respect to the Laplace domain is 1 upon s. Like if you are going to take the Fourier transform of the, you can say that the signal with the, you can say that multi-valued signal from minus infinity to plus infinity. You can say simply it's minus infinity to plus infinity, f of t into e raised to minus j omega t into dt. But here it's not like this. Here we have to go for the approximation. Here we have to go for the probabilistic modeling. Here we have to go for the estimation. So this classroom approach of solving traditional problem is not really applicable within the engineering field in general and within the electrical engineering field in particular, whether we are going to go for the industry or we are going to go for the research fields. Next slide, please. Okay. So according to the literature, the ill-structured problems require sufficient conceptual framework. So basically it needs understanding, a basic understanding towards solution of the problem by multiple ways. A basic understanding for solution of these problems with the help of the advanced engineering mathematics, not like simply solving by the matrix. We call this is idempotent matrix, this is Hermitian matrix, this is skew Hermitian matrix, not like this. But rather we have to go for the multiple ways. Now let me give you a simple example. Let's say whenever we are talking about the singular value decomposition, you might not have heard about this thing, but in the research work we normally have the singular value decomposition, right? So once I was learning what is singular value decomposition, what are the higher eigenvalues and what are the lower eigenvalues. So I asked from the professor that what is the higher eigenvalues, the eigenvalues with higher values, let's say 7.11, 7.22, 9.1, so on and so forth. And for the lower values, let's say 0.002, 0.001, so on and so forth. I asked from the professor, Prof, can you please differentiate me, or can you please tell me what is the exact difference between them? Now this is complex engineering. He told me the signals which have got higher values, higher singular values, they are supposed to be termed as a signal, and the lower singular values, they are supposed to be termed as a noise. Now this is something new, this is something novel, which we can easily learn only by having a conceptual framework, only by having an advanced understanding for the ill-structured problem, by only learning through the complex engineering base. Right? Next slide, please. Okay, what is implementation? How we are going to implement it? So according to the Washington Accord IEA 2015, it's a complex problem basically. So can't be solved without in-depth engineering knowledge, involved wide-ranging or conflicting technical engineering as well as other issues, have no obvious solution and require abstract thinking and originality in analysis to formulate suitable models, involve infrequently encountered issues, right? Next slide, please. Okay, outside problems encompassed by standards and codes of practice for professional engineering involve diverse group of stakeholders with widely varying needs, high-level problem including many components, parts or subproblems. Now, what we are going to do, basically the complex engineering problems, they involve the ill-posedness. They doesn't involve the linearity. They are not supposed to be solved by the simple superposition theorem, by simple Thevenin-Norton theorem. They are not supposed to be solved by simply applying 2 or 3 Maxwell's equation upon the easily solved boundary value problems. Rather, the boundaries are underdefined. The uncertainty is there. There is difficulty. There is ill-posedness. There is not a singular solution towards a singular problem. Rather, they have got multiple solutions for the multiple problem. So this is all about the complex engineering problem or the complex problem. That's somehow the confusing idea. Now, what we are supposed to do, how we can solve this complex problem? Because number first, there is no definite problem boundary. You normally heard about the BVPs, that is boundary value problems. Now, in case of, let's say, I'm going to take an example of whenever we are going to have source localization, let's say the brain source localization. So what we are going to do, we have got a brain model. Now within the brain model, we don't have a definite boundaries. We cannot limit the ideas and thoughts which are being generated by the brain. We cannot limit the signals which are being produced by the brain. We cannot limit the, you can say that we cannot set upon the boundaries upon the brain. So this is no definite problem boundary. Secondly, relatively no unique solution. In the mathematics, we used to term them as ill-posed, ILL-POSED, ill-posed problem. What is ill-posed problem? Which has got relatively no unique solution, and then no stability for the solution. You might have learned in the control engineering that whenever the poles are lying in the LHP, the system is stable, and whenever the poles are lying in the RHP, the system is unstable. So here, there is no stability. The stability factor is, you can say, apparently zero or tending towards zero. Multiple experiments are not possible. What to do? Next slide, please. What to do then? I mean, what is the criteria? Now, there are three communities where we can apply the complex engineering problems: the engineers, the technologists, as well as the technician. What the engineers are supposed to do, engineers requires in-depth knowledge that allows the fundamental based first principle analytical approach for the engineers. For the technologists, they require knowledge of principles and applied procedures, practical work, technologies. For the technicians, can be solved using limited theoretical knowledge, but normally requires extensive practical knowledge, technicians. Next slide, please. Now, there are some graduate attributes which are adopted by Washington Accord signatories, are generic to all engineering disciplines: electrical engineering, electronic engineering, computer system engineering, petroleum engineering, all the engineerings. What these attributes helps the signatories countries like US, like UK, Canada, Australia, New Zealand, Pakistan, Malaysia, Peru. What they help the signatories to develop the curriculum in accordance with the accreditation criteria. What these attributes have got a central role. Now, whatever curriculum we are, they're going to design, they are the traditional ways of learning. Now, the learning should be student-centric rather than teacher-centric. The learning should involve a highly complex problem in order that a student must learn the things which help he to develop his own ideas whenever he's going for the research work. The research work can be in any domain. Let's say it can be in seismic imaging, it can be in brain imaging, it can be in electrical power, it can be in energy domain, any domain. So within all the domains, if he or she is being helped through his undergrad material, then he or she has supposed to learn a good values, otherwise he cannot work. Okay, next slide, please.
Sorry, sir, for disturbing you, but please conclude because we have to come around.
So these are some of the attributes, engineering attributes, which are like engineering knowledge, depth and breadth and depth. So these from VA1 to VA7, all of them require complex engineering in order to be solve the engineering problems. Now let's say engineering knowledge, breadth and depth of the knowledge is being required, problem analysis is required, design and development of solution is required, investigation, modern tool usage like MATLAB, like Python, and so on and so forth. The engineer in the society, the level of the knowledge, as well as the environmental sustainability. Somehow, the level of the communication is also being included in the complex engineering problem. Okay, next slide, please. Now let's say one by one, if I'm going to discuss with you very precisely, because we have got we are short of time. So if I'm going to discuss with you that what is the engineering knowledge. So engineering knowledge is application of the mathematics, natural science, and engineering fundamentals, and on the engineering specialization of the solution of the complex engineering problem. Here you can see it involves the engineering fundamental, it involves the natural science fundamental, it involves the mathematical fundamental in order to solve the complex engineering problems. Next slide, please. Next slide, please. Okay, problem analysis, right? How we are going to solve the problem, to identify the problem. Sorry, please go back to previous slides, please. Slide number 2. Okay. Identify, formulate the problem, research literature, and analyze the complex engineering problem, reaching substance conclusion using first principles of mathematics, natural science, as well as engineering science. And we are going to solve the problem. The problems are being analyzed in such a way that they are going to address the complex engineering problem in a more efficient way in order to get a solved problem for the complex engineering problems, right? Next, please. Okay, design solution for the complex engineering as well as design systems, components or processes that meet specified needs with appropriate consideration for public health, safety, cultural, societal, and environmental consideration. Okay, next slide, please. Okay, investigation. Now, how we are going to investigate the problem? How we are going to take the complex problem? By using the experimental design, by using the analysis, and by interpreting the data, by using the statistical methods. We are supposed to interpret the data, that whether the data lies in the category of the descriptive data, whether the data lies in category, we have to see the trends of the data. We have to see that what distribution, whether they are binomially distributed, whether they are Gaussian distributed, or they are Poissonly distributed. We have to check out the distribution of the data. We have to check out the behavior of the data in order to interpret the problem and investigate the problem accordingly. Next, please. And then it comes the modern tool usage, the create, select, and apply appropriate techniques, resources, and modern engineering and IT tools. Now the tool usage is very important. We need to learn, being an electrical engineers, we need to learn different programming languages. We need to learn C, C++. We need to learn about the MATLAB. We need to learn about the Python, which is really emerging program tool for the machine learning and AI. So this is really important in order to solve the complex engineering problem. Whenever we are dealing with the, let's say, energy demand and supply curve, we need to learn about the Python. We need to learn about the C, C++ programming whenever we are going to have the machine design approach, right? Okay, next, please. And then the relationship of the engineer as society, the level of knowledge and responsibility, what you can say the responsibilities are being imposed upon the engineer by applying the reasoning informed by the contextual knowledge to assess societal, health, safety, and legal and cultural issues, responsibilities which are imposed upon engineers. They are also supposed to be solved through the complex engineering problems, right? Next slide, please. Okay, then environment and sustainability. How we are going to evaluate the sustainability of the environment? What is the impact of the professional work, being a professional engineer, like being an electrical engineer, being an electronic engineer? What are the responsibility of us to demonstrate the sustainability, to apply the sustainability within the environment? That also comes into the domain of the complex engineering problem. Next slide, please. Okay, then this is the ethics. This is not related to the complex engineering problem, but rather I was just telling you in general. So you can just skip through them. Next slide, please. Next slide. Ethics, and then we have got individual and teamwork. It's okay. Next slide, please. Then this is a communication. This involves the somehow. Therefore, I marked it in the pink region. So pink region means it is definitely, though we need to communicate in an effective way, but there should be a comprehension in writing and effective presentation. There should be comprehension in teaching telling your head that what you're doing in the complex engineering within the industry, and so on and so forth. Next slide, please. So then the project management, it's okay. You can skip this slide, please. Next, please. Finally, lifelong learning. So in my point of view, the lifelong learning be like if you have learned some of the skills which are related to the complex engineering problems, so they should be closely associated with your lifelong learning and how you're going to apply your understanding for whole of your life. If let's say you learned something in the Laplace transform, what is its application for the future? If you learn something for the Fourier transform, what is application for the future? Whether you're going to join a research field or you're going to join an industrial field, right? Next slide, please. Okay, so here we go. There is the range of the complex engineering attributes. Now, depth of knowledge is required, resolved with the forefront in-depth engineering knowledge, WK1 through WK8, and the range of conflicting requirements involve wide-ranging or conflicting technical, engineering, and other issues. Depth of analysis required, have no obvious solution, then how we are going to solve the problems. Familiarity with the issues involves infrequently encountered issues, and then we have got the extent of applicable codes and codes of practice, how we are going to think about the out-of-the-box solution. For the engineers, we must go for the out-of-the-box solution, and the extent of the stakeholders involved, and the level of the conflicting requirements, which involves diverse group of the stakeholders with widely varying needs, and then the interdependence that all level problems, including many component parts or subproblems. Right? Next slide, please. Okay, then complex engineering activities are summarized for the range of the resources, the diverse resources, how the peoples are being utilized, how the money is being utilized, what are the equipment which are supposed to be utilized, how the materials is being utilized, and for sure information technologies, level of interaction, what is the interaction between various components of the system, how we are going to understand the, you can say the relation between component, what is the correlation between them, how is the covariance between the two variables involved, whether the variables are random variables, whether the variables are deterministic variables. And then innovation involves the creative usage of engineering principles and research-based knowledge and novel-based. Novel-based means, as our conference title is innovations. So we must talk about the novelty. We must talk about the innovations. We must talk about the new things. We must talk about the novel ways to learn the subjects. These days, the arena or the area of the machine learning is quite in. So we should know about the machine learning. We should know about the supervised learning. We should know about the unsupervised learning. We should know about the reinforcement learning. And we should know how the tools and techniques which are being designed for the solution of the various machine learning problems are applied. Let's say Python is being applied. Let's say how MATLAB is being applied for the electrical engineering problem in general, and particularly in the field of the machine learning is being applied. So we should know about this thing, being an engineer. Familiarity can extend beyond previous experiences by applying principles based approaches, how we are going to apply the principle based approaches towards the traditional problems that's most important towards the novel problem with the help of the complex engineering activities. Right? Next slide, please. Okay. Now, what is the relationship of the complex engineering curriculum? We should develop the general modules learning. We should be clear. We should be more clear for the core and specialist electrical engineering subjects. Now, let's say electrical engineering core subjects, electrical power transmission is there, electrical power distribution unit is there. So we should be somehow impart the novelty in these subjects in order to learn the complex engineering problem. Not like traditionally going through them, that this is the approach, we have got the 5 current values and we are going to solve for the 5 mesh values. It shouldn't be like this. It should start from there, and then we should develop our understanding in order to solve the complex engineering problem from these simplistic problems in order to get our students more into the field of the complex engineering, in order to get our students. Yes, just I've got one slide, that's thank you slide. And just we can go through more into the ways of the learning of the complex engineering problem. Similarly, go for the good final year project as well as for the new learning. Okay.